Good morning! So today we're going to be doing a video on inequalities, just kind of the introduction and a little bit of basics and some tips to help you remember some of the symbols and what they mean. So I've got two examples drawn on the board. X is less than 2, and then x is greater than or equal to negative 4. So the way that I always remind my kids to remember these symbols is that this symbol, the less than symbol, literally draw it and it makes an L. So this makes this, therefore it means less than. This symbol down here is this way, minus this line on the bottom, the equal to sign. So this just the greater than symbol. You can literally make the word greater than once again. So therefore, this is less than, this is greater than. That's how we always remember the symbols. So x is less than 2. That means that when we are graphing it on here, I always put my number in the middle just as like a starting point, and then I fill in the rest of the numbers later. So if x is less than 2, that means that 2 is here. Any number less than that going this way is what x could be equal to. So it doesn't say x is less than or equal to 2, just less than 2. So that means it cannot be 2. So in order for it just to be less than, it's going to be an open circle. So it's an open circle at the 2 because it's not equal to it. It just has to be less than. So we also just pointed out that if it's less than, it's going this way. So all of these numbers here are less than 2, which means that all of these numbers could be a solution to this problem here. So let's fill in our number line. So we have 2, 3, 4, 5, and we're going backwards. 2, 1, 0, negative 1. So if I chose any number out of this section here, that should make this a true statement. So I'm going to choose 0. So if I plugged in 0 here, is 0 less than 2? Yes, so that means that this is true. So I'm going to put our x back up here. That was my check step. The other thing that I wanted to point out, as long as the variable is on the left-hand side, you can always use this little trick where you draw a line through the middle and it shows you the arrow that you're making here. It tells you which direction it's pointing. That only works if the variable is on the left-hand side though. So be very careful if you like that trick, which I do. Always have your variable on the left-hand side. So the next problem we're going to do is x is greater than or equal to negative 4. This is going to work the exact same way as the first problem did. We just have a negative number here. Don't let it scare you. I'm still going to put it in the middle. It can be placed anywhere. So I guess maybe I should put it somewhere else. I will say I'll put it right here. Okay, so it can be put wherever you want. It could be on this end, in the middle, anywhere you would like. So negative 4. Now, this has a line under it, which is the or equal to part. So x is greater than or equal to negative 4. That means instead of like up here where we had an open circle because they were not equal, I can close that circle because it could be negative 4. If I plugged in negative 4 here, negative 4 is greater than or equal to negative 4. It's not greater than, but it is equal to. So it could be a possibility. So here, I'm going to have a closed circle. Okay? Now, my variable's on the left, so I can use my little trick. I'm going to draw a line right here, and it shows me my arrow is pointing this way. Also think about it as the way that we just said it. X is greater than or equal to negative 4. So all those numbers that are greater than negative 4 are this way. So all of these numbers should help or work to make a solution for this problem. This is part of the solution set, which is a term that means a set of numbers that could be a solution to one of these graphs. one of these inequalities. So I'm going to fill in my numbers here. So -4, -3, -2, -1, 0, 1. Going backwards, -5, -6. Okay, so I can choose any number on here. And we already did -4. We already showed you that that was an example. That could be a solution. So I'm going to choose -2. So I'm going to take this x and I'm going to take it away here. I'm going to move this so that we can see our symbol. So -2 is greater than or equal to -4. Is -2 larger or going closer to 0 than -4? Yeah, -2 is only 2 spaces away, whereas -4 is 1, 2, 3, 4 spaces away. So that is a correct statement. That is a true statement, which means that everything we've done here on our graph is true, is correct. So this made it a little messy there, but it's just an example to show you. So when you are choosing a number to do for your check step to make sure that it works, you don't have to circle it. You don't have to do anything like that. You don't have to replace it with your problem. I would just over to the side, just do it, just small to the side as like a little check for yourself to make sure, hey, did I do it the correct way? Yes, I did. And our variable was x. So now we are going to start looking at one-step inequalities. So these are the exact same thing as one-step equations. There's just one slight change when you get to negative numbers. But we're not going to look at even negative numbers right now. So same thing that we would normally do for an equation. This is, you would put your railroad tracks over this symbol here, which normally is our equal sign, but we're doing inequalities today. So here we're trying to undo what has already been done. What has already been done? Well, they've added 4. So to undo that, we have to do the opposite of addition. So what's the opposite of addition? Subtraction, right? So we're going to subtract on both sides, because whatever you do to one side, you have to do it to the other. And we're going to subtract how much? 4. Right, so we want to get our variable all by itself. Remember, variable is the fancy term for this letter or a symbol that is representing an unknown value. So we are subtracting 4 here. So this goes to 0. And then what is 6 minus 4? 2, right? So we have 2. So this 0, we can normally leave it here to help us with our identity property of 0, but we're going to actually erase it and just bring down our x since I'm running out of room. So we have x. We're just going to slide our inequality symbol down. Now we have our final inequality, which is showing us x is greater than 2. So on our graph, to show this inequality, we have to put a 2, and then we're going to put an open or a closed circle. So we're going to have an open circle, right? Because we're not including this 2. There is no or equal to. It's just greater than. So that means x has to be greater than 2. So all the numbers that are greater than 2 go this way. So we're going to actually do all of these numbers here. So finish filling in your number line here. So if you want to do your check step, we can say, okay, so we have x is greater than 2. I'm going to choose 4 for my check step. So I will erase my x, plug in 4. Is 4 larger than 2? Yeah, I'd much rather have $4 than $2. Good job. This next problem, switched it up on us a little bit. I flipped this around so that our variable is on the right-hand side, because you will see that. So our variable is on the right-hand side, which for me is a little bit uncomfortable. I would personally prefer just to go ahead and switch it around and get it on the left-hand side. That way I can use the little trick that we had talked about earlier that shows me the arrow direction. So what I'm going to do is I'm going to look up here and I'm going to say, okay, I want the x on the left and I want everything else to flip. So if I put my x on the left-hand side, the mouth of the inequality sign is open towards the x. So over here, the mouth of the inequality sign needs to also be open towards the x. So I'm just flipping the sign over. And then the 7 is going to move to this side. And we now have the exact same problem, just written a different way, and a way that makes us feel more comfortable about it. So x is greater than 7. Now we can think about it that way versus 7 is less than x. They say the same thing, just in a different way, so it doesn't matter as long as you understand what it means. This way is more comfortable for me, and like I said, we get to use that trick. So now we have x is greater than 7, so that means I'm going to take my 7 and put it anywhere I want. I'm going to put it all the way over here this time, pretty far down the line, because we talked about you can put it wherever you want on the line, as long as you have room for your arrow. So there is no or equal to. So that means we cannot include the 7 in our solution set. So we have to have a little hole right here. It starts here, but there's a hole where the 7 is. Anything else that's greater than 7 can be included in the solution set. So we have our 7 starting point. We have our open circle. And then I can, because I've switched it, I can use this trick to show me my arrow is pointing that way. Also, you think about it, all of these numbers to the right are all greater than 7, which means it follows our inequality. So all these numbers here will be part of my solution set. So I'm going to fill in my number line. And it doesn't matter how many tick marks you have, as long as you have a couple. So now I have x is greater than 7 right here. We're not including 7. Any of these numbers are greater than that, so I can choose one for a check step. I'll choose 11. Is 11 greater than 7? Yeah, 11 is bigger. I'd much rather have $11 than $7. So that means we did it correctly. That means we've graphed it correctly. Good job. All right, so we're going to do another one-step inequality problem. I've switched it up a little bit. Hopefully you can tell I've used a different operation. And our variable is now on the right-hand side again. So we're going to do same stuff we would normally do to solve an equation. It's just an inequality. Okay, so first of all, draw your train tracks. Right over that inequality symbol, which is normally our equal sign. So that is what is separating one side of the equation from the other side. Okay, so looking here, we want to get the variable by itself. So our variable this time is an n, not an x, because you can use whatever you want, right? So we have to figure out what has been done already. Well, what has been done? Well, they've subtracted 7, so we have to undo that. So the opposite of subtraction is addition. So we're going to add 7. Is that all we're doing? We have to add to both sides. Good job. Whatever you do to one side, you have to do it to the other. So we are adding 7 on both sides of the equation, or excuse me, the inequality. So this gives you 0. I'm just going to bring down my variable. 12 plus 7 is 19. Very nice. And then I'm just going to slide my inequality symbol down. Now, what is happening here that we don't particularly like? I'll give you a hint. It has to do with the variable. So the variable is on the right-hand side, right? I prefer to have a variable on the left-hand side so we can use that little trick to help us just make sure that we're graphing it correctly. So I'm going to flip it. So I'm going to have my n on this side. I don't need that big of a swoop tail. I'm going to have my 19 on this side. And then I'm just going to look at this. The mouth is open to the n, so it needs to be open to the n this way. And then I'm going to draw my line back underneath it. So we have n is greater than or equal to 19 now. So now we have to use our, number line to graph it. So I'll take my 19 and I'm going to put it, I'll put it here this time. 19. All right, so we have a line underneath. That means or equal to, right? So that means we can include the 19 in our solution set. So this 19 here is going to be a closed circle. So we have a closed circle, and the n has to be greater than or equal to. So we've already got the or equal to part down. Now it has to be greater than. So all of the numbers going this way are greater than 19. So this would be where the solution set would lie. And I put it on the bottom here because I ran out of ran out of room on the top here. But normally you would put these on the top to graph. So I'm adding in the numbers that go on my number line, and then I'm going to pick one to do my check step. So I just chose 23 at random. So here I would say, okay, 23 is greater than or equal to 19. All I did was take the 23 and replace it with the n here so that I could check to see, is this a true statement? Is 23 greater than or equal to 19? Yeah, 23 is larger than 19. So check, we did it right, and our graph is right. So here's another one. This one is a little bit different. We are using a different operation here. So we are going to draw our railroad tracks like we normally would. Right, and then we have x divided by 3 is greater than or equal to 7. Our variable is on the left-hand side, so that's good. But we have to figure out this is what's being done, so now we have to undo it. So how do we undo divide by 3? We have to multiply by 3, right? So we're going to multiply both sides of the equation by 3. When you do that, this 3 divided by 3, because this is on top of a 1 like this, right? So you have 1 x, which is also just x, okay, because 1 times x, or 1x is just x. And then you have 7 times 3 is 21, and we'll bring that down. So now we just divided like normal. We just used positive numbers, so we're going to slide this inequality sign down here. So now we have x is greater than or equal to 21. And then we are going to graph that right here. Remember, you can put your number wherever you want. So I'm going to put mine in the middle. And or equal to. This line right here means that you have to include this 21. So this is going to be a closed circle. We are including this. And then I can draw my line saying, oh, it's going this way. So check right here. Are all of these numbers greater than 21? Yes. So this is the greater than, this is the or equal to part. So fill in your rest of your numbers here. 18, 22, 23, 24, 25. Choose a number, do your check step. So let's just choose, let's choose 21 this time, okay? So now we can say, okay, is 21 greater than or equal to 21? Well, is 21 greater than 21? No, they're not greater than. They're the same, right? So 21 is equal to 21. So that checks out, so that means we've done it correctly. Good job. Two x is less than 8. That's the new problem we have. So we're going to draw our railroad tracks here. This is multiplication. Multiplication is happening right here. You can draw yourself the little multiplication dot if that makes you feel better. 2 times x is 2x. So, what's being done here? Well, we just said that. It's being multiplied by 2. So the opposite, so we have to figure out what's being undone, the opposite, which is divide by 2. So if we divide both sides of the equation by 2, 2 divided by 2 equals 1. And then you can bring down your x, so you have 1x. 1x is just x. You don't have to have the 1. Oh, x. There we go. And then the other side of the equation, 8 divided by 2. What's 8 divided by 2? 4. Good job. So now we can just slide this down. It was just basic multiplication and division. X is less than 4. So let's draw our graph, our number line here. I'm going to put my 4 over on this side now. Okay. Now, we have no line under here. There's no or equal to. So that means that this is an open circle. Okay, we're not including that 4 as part of the solution set. And then it's less than, we can draw our line here. It shows you, oh, it's going this way because our variable is on the left, so we can use this trick. So that means that our line is going to go this way. All of these numbers that we are passing should be less than 4. If they are not, then we have done something wrong. We need to go back and check. So fill in the rest of your numbers. Now we can choose a number, okay? -1, I'll choose that. Is -1 less than 4? Well, would you rather have $4 or would you rather be in debt $1? 4, because that's bigger, right? So that means we have done it correctly. That's our check step. Good job. So the next problem that we're about to do is still a one-step inequality. However, this is what makes inequalities different from equations. This is the main difference that we need to keep in mind when we are doing inequalities. Anytime you're doing inequalities, you're trying to solve for the variable. If you multiply or divide by a negative number when you're working through the problem, then you will flip the sign. Okay, so this example is going to help show how that works. It's -2x is less than 6. Remember, this is multiplication happening already. It's already happened, right? -2 times x makes -2x. We're going to draw our railroad tracks through here. Okay, so the opposite of multiplication, we have to undo that, is division. So we're going to have to divide both sides by this number here, the -2. So if we're dividing by a negative number, then we have to flip the sign. So when we bring the sign down for this next part here, you're going to flip the sign. Instead of being facing this way, it's going to be facing this way. So slide it down, go ahead and flip the sign while you're doing the operation that you're talking about with the multiplying or dividing. In this case, we're dividing. So the negatives go away. 2 divided by 2 is 1. So we have 1x, which we know means just x. We have flipped the sign because we divided by a negative. Now, 6 divided by -2. Remember, if you're dividing by a negative number, a positive divided by a negative is still going to be a negative. So we'd have negative, and then 6 divided by 2 is 3. So this should be the final solution set here, and then we have to graph that. You're going to graph it the exact same way that you graphed all the rest of them. You've already flipped the sign, that's all you had to do here, and then just graph what it says. So, I'm going to find a place, I'm going to put my -3. There is no line, there's the no or equal to part, so we don't have to include this in our solution set. So it's going to be an open circle. And then variables on the left, so I can use my trick right here. Oh, it's going this way. If we said it out loud, x is greater than -3. So all these numbers to the side here are greater than or bigger, right? So we have -2, -1, 0, -4, -5, -6. So if we wanted to check ourselves, grab a number here. Is 0 greater than -3? Yeah, it is. I would much rather not owe any money than to owe somebody $3. Right? The 0 is larger than the -3 because it's farther to the right of the number line. Here's another one with our negative numbers. We talked about that being the big difference between inequalities and equations, right? These are talking about solution sets and have this big, like, if you multiply or divide by a negative number, you have to do this, right? Which is flipping the sign. So, looking up here, we can go ahead and draw railroad tracks going down. And we can say, okay, n is being divided by -4. So the opposite of division, which is undoing the problem, is multiplication. So we have to multiply both sides of our equation by what? Yes, the denominator here, so -4. Don't forget to bring that negative with you because that's important, right? So if we're going to multiply one side by -4, we have to multiply the other side by -4 as well. So here, this goes away, right? Because that gives you 1, and then we can bring down our n. 1n is equal to just n by itself, right? But we have just multiplied both sides of the equation by a negative number. If we're multiplying both sides of the equation by a negative number, you multiply or divide by negative, you have to flip this sign. So the mouth is opening to the left side, so it should flip and open to the right side. So I'm going to flip that around, and I'm going to have it opening this way. I keep the line underneath. It should still be the same. If it's an or equal to on the top, it should still be an or equal to on the bottom. All you're doing is flipping it to the other side. Okay, so now we have -3 times -4. Now, I always have told my kids in the past, and I will tell you now. Think about a ninja, right? Negative times a negative. It's a positive. You'll never forget that now because I just made a fool of myself on this video. A negative times a negative is a positive, right? So this means -3 times a -4 is a positive 12. Negative ninjas here coming at you. Okay, so now we have, this is our solution set. N is less than or equal to 12. Go ahead and graph it like you normally would. Do a short graph here. Put my 12 in the middle. And then this or equal to means we have to include that 12. It could be could be one of the answers, right? It's just part of the solution set. So if it's less than, the variable's on the left. So I can use this little trick. All these numbers here are less than 12. So you can use this right here. Is 11 less than or equal to 12? Yeah, 11 is less than 12. So, you've graphed it correctly. So talking about multiplying and dividing with negative numbers, I went ahead and drew up here for us all of the things you need to know about multiplying with negative and positive numbers. So if you're multiplying two positive numbers, a positive times a positive is a positive, okay? If they're the same, it gives you positive. So a negative times a negative is a positive. That was that math ninja, right? Negative times a negative is a positive. All right, so if the two are the same, meaning both positive or both negative, they give you a positive answer. If they're different, so a positive times a negative or a negative times a positive, it will give you a negative answer. So this is very important. If you're taking notes on this video, write it down in your notebook somewhere. Exact same thing goes for dividing with positive and negative numbers. If you're dividing positives, gives you a positive. Dividing both negatives, it gives you a positive. So they're the same on top and bottom, gives you a positive. If they're different, one is negative and one is positive, whether it's the numerator or denominator, it will give you a negative answer. So once again, super important to write down in your notebook. So glad you guys came and joined me today. I hope you enjoyed the video. Remember to like and subscribe and comment down below so that you can get all the notifications of new videos as they come out. And I'll see you guys on the next one. Bye!